Hello, AP Calculus AP students. So this is my video where I am going over the quiz packet that is due on Friday. Now, I implore you, as you are using this video to your benefit, please, you should be working through the problems yourself and using this video as an aid. If you get stuck or if you really just forgot how to do a problem entirely, watch it. But you need to do the learning basically. So you should not be using this video to just write down the work. You are gaining literally nothing from that besides points in the class, which at this point, we're working more towards the AP exam rather than that. All right, so this first page, I'm going to say concept for page 1. I will say this first page is a problem. I dedicated 3 problems to this concept because it's one that looks difficult, but it's really not. All right, so don't panic. Really, what are they asking for? This, notice the limits is h as approaching 0, limit as h approaches 0. All this limit is it comes from the same concept, which is the limit definition of a derivative. So I'm going to write that down. Limit definition of a derivative. This is as we were transitioning at the beginning of the year into derivatives. And this is what the limit definition is. The definition is as the limit of h and approaches 0 over f of x plus h minus f of x all over h. All right. Now, you may or may not remember this. This is from very, very early in the year. Really, what this limit is saying is it is the slope of a secant line. So notice which choice represents the slope of the secant line shown below. It's this f of x plus h minus f of x all over, really, that's just h, right? So what's happening, this defines a derivative because as h approaches 0, that means that these 2 points here of the secant line, so you might not be able to see my cursor very clearly, but these 2 points, they get closer and closer, which tells me simply my slope. It's no longer the slope of the secant line, it just becomes the slope of a tangent line, right? So that's essentially what's going on here with this. Now, that means I can just make sense of this, right? What is this really asking for? It's simply asking for the derivative, right? So I don't need to overthink it. I don't need to even solve for the limit. I'm just simply asking for the derivative. All right, so let's solve for the derivative. I need to solve for my derivative, right? Well, the question is, what is my derivative? Or what's my function? What's my derivative? All that sort of stuff. Well, remember, this fits into this structure. So what do I know? 16 plus h, x plus h. So I know my x is equal to 16, right? That I know, it fits into this structure, right? X plus h, x plus h. What else do I know? The function, that's what I plug it into. I plug my 16 plus h into the function something to the 1/4. So for my f of x, my function is really just x to the 1/4. Right? That's what it's shown here. My f of x, my function is x to the 1/4. Right? Excellent. So that's really all the information I need. Right? I know my x is 16, and I know my function is x to the 1/4. So let's just solve for my derivative, because again, I'm just asking for the derivative, nothing else. So what's my derivative? Well, my derivative is equal to, this is a power rule, 1/4 x to the negative 3/4. All right, 1/4 x to the negative 3/4. Now, I'm going to now plug in 16. F prime of 16 is equal to 1 over 4, 16 to the negative 3/4. And for this, I'm actually totally fine if you use a calculator. If you solve for this, this ends up being equal to 1 over 32. Straight up, my answer is B. Okay, so I want you to see if you can effectively apply this concept to the rest of the problems, right? And that might be sort of challenging, but actually I'm going to skip these next 2. But remember, both of these, what are they asking for? They are simply asking for the derivative. That is it. They're simply asking for the derivative. And what structure does it follow? Well, it follows the structure of the limit definition of the derivative. Limit definition of the derivative, which I would write this down multiple times to make sure you got this remembered. You have your slope of a secant line, which is f of x plus h minus f of x all over h. But remember, the secant line, the 2 points are getting closer and closer to show that my h is approaching 0. H is approaching 0. So it follows this structure. Both of these follow that structure. Based on that, I want to see if you can figure out what the answer is. Try your best on this. Again, this is mostly effort grade. I want to see that you're thinking through this and can come to deductions yourself rather than just watching and writing and copying stuff down. All right, let us move on to the next page. All right. Let f be the function given by f of x equals f of x cubed minus 3x minus 7. What is the value of f prime of negative 2? Well, this one's pretty easy. F prime of x would be equal to 15x squared minus 3. That is just a power rule, right? That means I plug in negative 2. F prime of negative 2 is equal to 15 times negative 2 squared minus 3. Just make sure you are doing your arithmetic correctly. 15 times parentheses negative 2 squared, that's 15 times then 4, then minus 3. 15 times 4 is 60, minus 3 is equal to 57. My answer is D. All right, hopefully that makes sense. Cool. The graphs of the linear function f and g are shown above. If h of x is equal to f of x plus g of x, then h prime of x is equal to what? Well, let's figure out what h prime of x is based on the fact that I'm given h of x here. H prime of x. So I could see how we might make a mistake by thinking, okay, derivatives, what derivative rule do I need to apply to f of x plus g of x? Like, is it product rule? Is it quotient rule? Well, there's no real rule, right? We're just adding two functions. So h prime of x is just going to be f prime of x plus g prime of x. Right? It's just, I take the derivatives of both of them. All right. Now, cool. Then they ask for what h prime of x is, and a question is, I would have is, well, what is x? What is x? What do I plug in? Right? They don't tell me to plug in anything. So how am I supposed to get to a numerical answer? What do I plug in? But if we take a look at this chart here, we'll realize f prime of x, right? F prime of x equals slope of f of x. Right, I'll write that here. G prime of x is equal to the slope of g of x. Right, hopefully you understand that concept. Well, that doesn't change. F prime of x, this is a straight line. The slope is not changing. So I can just write what this is. F prime of x, let's calculate this slope. Well, let's see. F prime of f of x, I'm just going to choose any random 2 points. So I'm going to start here. I go up 2 and over 4, it looks like. So my change in y is equal to 2. Change in x is equal to 4. 2 divided by 4, my slope is 1/2. All right, slope is 1/2. All right, let's do the same thing with g of x. See, I go over to the left, 3 down 3. So 3 divided by negative 3. That means my slope is negative 1. All right. And that means I know my f prime of x. I don't even have to plug anything in because it's always going to be 1/2. My g prime of x is always going to be negative 1. So let's just plug it into my equation. H prime of x is equal to f prime of x 1/2 plus g prime of x negative 1. That's equal to negative 1/2. My answer is C. All right. Hopefully that makes sense. All right. We're going to continue. If f of x is equal to ln of x times cosine of x, then f prime of x is equal to what? First thing that should jump off to you, okay, here we're getting into derivative rules, right? These two are multiplied together. I should be using what rule? It is going to be a product rule. If it were me, I would have my product rule memorized and written down just so I don't make any mistakes. VU prime plus UV prime. Try not to skip steps. Not writing stuff can be the first step to a mistake. All right, so let's write U, V, U prime, V prime. I still do this every time I do product rules. So for those of you who do it in your heads, try not to do that. U is ln of x, V is cosine of x. U prime should be 1 over x. That is an identity, right? Derivative of ln of x is 1 over x. Derivative of cosine of x is negative sine x. Cool, I plug it into my equation. VU prime, that's cosine of x. I guess I use parentheses. Cosine of x, 1 over x, plus UV prime, so ln of x, negative sine x. Cool, let's sort of simplify this, because if you'll notice, some of these, they're not written the same way, right? So cosine of x times 1 over x, that's actually just really cosine of x divided by x, right? Then plus natural log of x times negative sine of x, I'm going to distribute the negative or just multiply it out. So now it's minus ln of x sine of x, right? Minus ln of x sine of x, however you want to write that. I guess I could write that ln of x sine of x. All right, which of these looks like that? It is clearly going to be C. Okay, hopefully that makes sense. Now, the graphs of the linear function f and the piecewise linear function g are shown in the figure above. If h is equal to f of x times g of x, then h prime of 3 is equal to what? Now, before you just jump into finding the slopes, remember, this is also a product rule, right? And this is different from this question, right? Different from this question, because there's a plus sign here. This is not a product rule. So that's why there's actually some differences. You have to make sure you really understand what they're asking you to take the derivative of. Here, derivative of f of x times g of x. Let's do my product rule then. So u is equal to, here, actually, I'll write out my product rule. It's v u prime minus u v prime. My u is equal to f of x. My v is equal to g of x. U prime is equal to f prime of x. V prime is equal to g prime of x. Cool, I plug it into my product rule. V u prime, that's g of x, f prime of x, minus f of x, g prime of x. Excellent. There is my product rule equation. Now, unlike the last problem, they actually asked me to plug in 3, right? So I'm going to plug in g of 3 times f prime of 3 minus f of 3, g prime of 3, right? So let's figure out what these each are, right? So g of 3, how do I solve that? Well, I'm given my function g of x right here. So I'm just going to go to 3, and I'm going to pick the y value. The y value is 3. So g of 3 is going to be just 3. All right, just 3, right? Then f prime of 3, what is that? Well, be careful. Don't just look at f of x and say f of 3 is like 4 or something. Remember, f prime of 3, they're asking for the slope at 3. So I'm going to go to 3. F of x here, I'm going to look for the slope. What is the slope of that line? Hopefully you can calculate that. The slope of that line should be -1, just looking at that. All right. Then minus f of 3. Here I don't have to calculate for the slope. I just go to 3, find f. It is 4. So it's going to be 4. All right. G prime of 3. That means I'm going to go to 3, go up to g, but I'm going to find the slope. The slope there, hopefully you know how to calculate that, should be 2. Should be 2. All right, so that means my final answer is -3 minus 8. It is -11. My answer is A. All right, hopefully that makes sense. Okay, let f be the differentiable function such that f of 2 is equal to 2, f prime of 2 is equal to 5, g of x is equal to x cubed, f of x. What is the value of g prime of 2? Okay, so what am I starting to look for? That's a lot of information. What am I looking for? I'm looking for g prime of 2, the derivative of g, right? Well, g of x is given here, and I can see it's clearly going to be a product rule, right? That's my u and v. Product. Right, so let's label my u is equal to x cubed, v is equal to f of x, u prime is equal to 3x squared, v prime is equal to f prime of x. And this might be weird for y'all, the way this is written, but again, just follow the structure, follow the steps. Right now, I don't know what f of x is, right? So I'm just going to take the derivative f prime of x. That's fine. Okay, I'm going to plug it into my product rule. My product rule, again, is vu prime plus uv prime. Okay. vu prime plus uv prime. Well, let's plug that in. V is f of x times u prime is 3x squared plus uv prime. That's x cubed f prime of x. All right. Cool. What x value am I plugging in? I'm going to plug in 2. So that's f of 2 times 3 times 2 squared plus 2 cubed f prime of 2. All right. Now let's just figure everything out. F of 2 is 2 times 3 times 2 squared. So that's times 3 times 4. All right. Hopefully that makes sense. Plus 2 cubed is 8 times f prime of 2. They give that to me. So it's 5 times 5. All right. So let's solve for all this. 2 times 3 times 4. That's 24 plus 40. So my final answer is 64. All right. Hopefully that makes sense. Okay, let's move on. Cool. Let f be a differentiable function such that f of 8 is equal to 2 and f prime of 8 is equal to 5. If g is the function defined by g of x equals f of x divided by cube root of x, what is the value of g prime of 8? All right, again, a lot of information. What am I asked to find, though? I'm asked to find the derivative of g. Derivative of g. Okay, what rule do I use to find the derivative of this? Well, it's a quotient rule because two things are divided, right? So you got to be able to recognize this stuff. All right, what is my quotient rule? It is vu prime minus uv prime all over v squared. This should be memorized. All right, let's write everything down then. My u is f of x. V is cube root of x. U prime is f prime of x. And v prime is, how do I solve for that? Because let's say I don't know the rule for this, right? Cube root of x. How am I supposed to solve for that? Think about that. Rack your brain, see if you can remember how to solve for the derivative of this. And I'll tell you, right, what you have to do with these radicals is you're going to need to rewrite it. So this is really x to the 1/3. Right? That means the derivative is going to be 1/3 x to the negative 2/3 via power rule. So check, make sure you got all of that. All right, so I'm going to plug that into my quotient rule then. So v u prime, that's going to be, let's see, my v is cube root of x times u prime, so that's f prime of x minus u, which is f of x, v prime. That is, that's kind of a lot to write, 1/3 x to the negative 2/3 all over v squared. So that's all over cube root of x squared. Yeah, let me write that a bit better. All right, now, what am I going to plug in? I'm going to plug in 8. So this is actually, when I did this, it's sort of a lot to solve. So I'd be fine if you use a calculator, but we could theoretically solve this without a calculator. I plug in 8, right? F of 8, 1/3 8 to the negative 2/3. And then I continue with the denominator is cube root of 8 squared. All right, now a matter of solving this, like I said, you could use a calculator for this. It really would not be the biggest deal. Cube root of 8 is 2, right? So yeah, I'm gonna just go step by step. It's 2, right? F prime of 8, they give that to us, that's 5, minus f of 8 is 2 as well, times 1/3. Now, 8 to the negative 2/3, how would I write this? Well, 8 to the negative 2/3 is really, I can write that as first 1/8 to the 2/3, right? That's also equal to 1 over the cube root of 8 squared. So I'll show how you would do this step by step. 1 over cube root of 64. Cube root of 64 is 4, so it's really 1 over 4. So this whole thing turns into 1/3 times 1 over 4. Right? All over cube root of 8 squared, so that's 2 squared. All right, simplify this. That's equal to 10 minus 2 over 12 divided by 4. That's 10 minus 1/6 divided by 4. To combine 10 and 1/6, I'm going to rewrite 10 as 60 over 6 minus 1/6 over 4. That's equal to 59 over 6 divided by 4, which is equal to 59 over 24, because 6 times 4, or 59 over 6 divided by 4, I multiply the denominators. That's 59 divided by 24. My answer is A. All right. Now, here, the second one's very straightforward. I'm going to have y'all do this one. Now, the last problem, I guess I'm going to start off this problem, and I want y'all to finish it, right? So again, looking at this, 6f of x divided by g of x minus 1, what rule am I going to use? Obviously, it is also a quotient rule. All right, so what I would do is I just copy down my quotient rule, so I always have that to fall back on. VU prime minus UV prime, all over V squared. Right, now, let's plug in all my materials. So my U is equal, or sorry, not plug in. U is equal to 6f of x. V is equal to g of x minus 1. Now my U prime, derivative of 6f of x. So something that people, like, this is the part where people start overthinking, like they start looking at the table. Don't look at your table yet, right? You know the steps you need to do. Don't look at the table until you have to look at the table. So derivative of 6f of x, that's 6f prime of x, right? I can take the derivative of it, so there's no reason to look at the table. V prime is going to be g prime of x. Cool. Now, is there still a reason to look at the table? Not yet, because I can just plug in this stuff into my quotient rule, right? So let's just plug in VU prime. That's g of x minus 1 times U prime is 6f prime of x minus 6f of x. 6f of x times v prime, which is g prime of x. All right, let me make sure all over v squared, so g of x minus 1 squared. Cool. Now I plug in h prime of 0, so each of these, I'm not going to rewrite this all, but each of these is 0, right? So I'll write 0, 0, 0, 0, 0. Still haven't even looked at the table. Okay, now they're asking me to solve this. Now I need to look at the table, right? Because I don't know what g of 0 is. So you look at the table when you need to look at the table. G of 0, according to this table, is -2. So -2 minus 1 times 6 times f prime of 0. That's 6 times 1/2 minus 6f of 0. That's 6 times 4 times g prime of 0. That's 3 over 2 over g of 0, which is -2 minus 1 squared. All right. So effectively, you're now just going to solve this, and I want you to determine the answer, right? You just arithmetic and solve it. Okay, hopefully that was helpful in the multiple choice. Yeah, if you're at the end of this for the free response, there will be videos for that as well, likely other sources.